Okay, so number 10 is saying, what if we are asked to find extrema, the EBT does not apply, no interval is given, and we don't have a graph? Yes, you assume the fetal and you just cry yourself to sleep. Okay, so it says find the extrema for each of the following functions over their domain by sketching the graph. So, what where do we know that f of x does not exist? And okay, good. So if I draw myself a graph, I got -2 and I get +2, right? So if I plug in +2 and -2 into that equation, what am I going to get? Okay, right. So f of 2 is 1/0. Okay, so what does that mean? It does not exist, but what else do we know is like happening on the graph? It's a vertical, right? So that means we have a vertical what? Not tangent, but asymptote. Okay? So anytime you get, 1/0, that means it's going to go off towards infinity. All right? Also, -2 is going to give you the same thing. So that's also going to go off towards infinity. Yeah. Okay. Now, what other point could we possibly figure out? Say, like, the y-intercept. So when I plug in 0, what am I going to get? ½ right? Okay. So I know I have a y-intercept of 1/2, and I know that as I go to 2 and -2, the graph is going to go towards infinity. So it will look something like that. So based off of that graph now, do you have a maximum value? So there's no max, and what about a min? So you have no max, and you have a min of 1/2 at x equals 0. Okay, good. Yes. All right, letter B, you have a piecewise. So the easiest way to do this would be to, again, sketch the graph. All right, so if you plug in 1 into the function from the left, what are you going to get? If I plug in 1 from the function on the left, I'm going to get +3, right? So that's a closed circle there at 3. If I plug in 0, I'm going to get 5. And this is a quadratic. Leading coefficient is negative, so it's going to go kind of upside down. Well, it's good to look for the y-intercept, so you know where it's going to cross the y-axis. Now, x plus 2, if I plug plug in 1, I'm going to get 3, right? So, and then you have a slope of 1, right? So your line's just going to kind of look like that. Sharp, right, yeah. So, do you have a min or a max? It's at 0. Right, but if you're going to give a location, you have to say at 0. All right, so there's no min, there's no max. And what do we have there at x equals 1? What would that be? Right. You have a relative min at x equals 1. Because, what is this? This is g. Since g prime of 1 does not exist. And again, what's it at relative min at x equals 1? What's the graph doing to the left of 1? Is it increasing, decreasing, or what is it doing? It's decreasing, right? So if this is decreasing, that means that your derivative is what? Negative, right? And then over here, my function is, so my derivative is positive, right? So that is where, that's what kind of where we're going, is to figure out relative extrema is you want to see where does the, your derivative kind of change signs. Where does it go from negative to positive or positive to negative? All right, number 11, we want to use the calculator. Yeah, I guess you can see, yeah. So relative max at x equals 0, since g prime of 0 equals 0. Good. All right, number 11 says, find the extrema of f of x on the interval from -1 to 1. Be sure to show the equation you're solving and your justification. Okay, so I know that I have to test -1 and 1, and I also need to find what? Extrema occurs at either endpoints or what? Critical values, which is when the derivative doesn't exist or equals 0, correct? All right, so e to the negative x is a continuous function, right? And so is a 2x or x to the first. All right, so what we want to do is we're going to put f of x into y1, and then we're going to put its derivative into y2, yes. All right, so what you're going to do is you're going to put in f of x into y1, and then the derivative into y2. You have the older one, yes. Alright, so I got x, e, and negative x minus 2x. Alright, so what's the interval that they're giving you? So you guys should want to change your window to be from -1 to 1. -1 to +1. Not yet. This is the original, right? So we're looking at it from -1 to +1. -1 to 1, -10 to 10. Alright, so let's change the y min and y max so it's a little bit closer. So let's change that to be -4 to 4. Yep. Are you good? Alright, now what I want to do is I want to put the derivative into y2. So how do we get the derivative to come up? Math number 8. Okay, what you're going to do is you're going to type in math 8. Now, you can either retype that equation or you can hit the vars button, which is right next to clear. You're going to scroll over once for y vars, hit enter for function, and then you're going to hit enter for y1. Alright, so this is telling your calculator I want you to figure out the derivative of y1. So you should have y1 comma x, so you're taking the derivative with respect to x, and then when you want to graph the derivative, you have to put x again, close parentheses. So if you have the old operating system, this is what it should look like. And then you're going to hit graph, right? All right, now it is going to take, some time because it's doing a lot of crunching right now. Okay, so this is the red line again is your derivative, right? And we're trying to see where does the derivative equal 0, which would be right here, right? So go back to y equals, and you're going to put in 0 into y3. So you should have the original equation, the derivative, and then 0. And you're going to hit graph again. If it's like in black and white, you're not really going to see it. That's right. Okay, what I want to do is I'm going to figure out exactly what this value is. All right, I want to see where does the red line intersect with y equals 0. So that's going to tell me where does my derivative equal 0. So you're going to hit second, trace is up here. It is next to the graph button. That's going to bring up your calculate menu. And you're going to go down to number 5 for intersect. Okay, and then you're going to hit enter. Okay, now, most of you guys, was the blinking X that created 0, 0? Yes. All right, what I want you to do is hit the down button once. All right, so it was on the blue line, it was on the blue curve. We don't want to use the blue curve. We're not really interested in him right now. All right, if you hit the down button once, it's going to go right onto your derivative. All right, so you're going to move this X closer to where it intersects with the axis, and you're going to hit enter. And then you're going to hit enter again, enter a third time. All right, go back to y equals. All right, go to y1. And what you're going to do is highlight the equal sign, and you're going to hit enter. All right. What this is telling the calculator is that I don't want you to graph y1. All I want you to do is graph y2 and y3. All right. So your equals sign should not be highlighted. You go to the equal sign and you hit enter. Okay. So now hit graph again. So now all it's going to do is it's going to give you the derivative and then y equals 0. All right. Again, we're trying to figure out where does this derivative equal 0? Where does these two intersect? So, second, trace, calculate menu. Get down to number 5. You're going to hit enter. And again, move this closer to where the intersection is, and then hit enter 3 times. Because it's limited in what it can do. Yeah, but it can be, if you do it here, or whatever, you're still going to get the same answer. So 1, 2, 3. Okay, so I have a critical value right here at negative 0.374, right? Okay, I'm going to have to test that into my equation. So what I want to do is I want to store that into my calculator. So you're going to go to the home menu, so hit second, quit. And what you're going to do is you're going to hit X. Can you wait? All right. So you're going to hit the X variable, and then you're going to hit enter, right? What it did is it stored for you your answer that we just found, that intersection, okay? And what I'm going to do is I'm going to store that as a letter. All right? So, you're going to hit store. So STO, which is here at the bottom, you're going to hit that button. And then you're going to hit the green button for alpha. So this is telling me store my answer as alpha, and then hit the math button for A. So what? All right. So again, hit the store button, and then you're going to hit the green button, and then the math button. Second, trace. Second, trace. Number 5. going to move it to the left, hit enter 3 times. 1, 2, 3. Yes. I don't know why it's taking forever. So you got the same thing that I did. So you're going to go to the home screen, you're going to hit X, enter, store, green, math. Okay, so what I just did is I stored this number, this value now, as A. So when I have to go plug it back in, it's going to be easy for me to find. All right, so go back to your paper now. So you should write down f of prime of x is equal to 0 at x equals negative 0. What was it? 378. Okay. So if this was like an open-ended question, right? You're telling you found the derivative, right? You set it equal to 0, and you found that that's your value. All right. What you then want to do, because you stored it as letter A, you want to let the reader know that you stored that as A. Okay? Because the next part that you do, right, we have to evaluate the 2 endpoints, and then we have to evaluate the critical value, which is this point here. So when you write it next on your paper, you're going to do f of negative 1, f of 1, and then f of A. So they know that, okay, what does this guy mean that what's this letter A stand for? Okay, A stands for this, and he found that by setting the derivative equal to 0. They're going to be able to follow your thinking process. All right, now we have the original equation stored as y1. Okay, so you are going to hit, again, the bars button. Scroll over once to the y bars. Hit 1 for function, 1 for y1. And then you're going to evaluate it at negative 1, because that's your first endpoint. And then hit enter. So the original equation at negative 1 gives me negative 0.718. Okay, you would write that on your paper. Negative 0.718. Negative 0.718. All right, you're going to do the same thing again for 1. So if you just want to hit second, enter, it gives you the same thing back, and then you can just type in, just get rid of the negative, and then hit enter. Okay, so at 1, that gives me negative 1.632. So you're going to write that on your paper. And then the last one you have to do is you're going to evaluate it at the critical value. So instead of having to type that entire number in, all you have to do is just type in the letter A. So you're going to hit alpha, and then A, and then hit enter. A would be the math button. All right, so that gives you 0.204. All right, so based off of that, you have a absolute max at letter A, right? So you have a max of 0.204 at x equals negative 0.74, and then you have a min of negative 1.632 at x equals 1.